Hello, so today we are going to do this problem called minimum difficulty of a job schedule, which is part of Leetcode October challenge. So the problem says we want to schedule a list of jobs in exactly D days, and these jobs are dependent, which means to be able to work on the ith job on a specific day, you need to have worked on all the jobs before it in either that day or the days before. And each day you have to finish at least one task. And we mark the difficulty of a schedule as the sum of the difficulties of all days, of all D days, right? And now the question is, what's the difficulty of a day? Well, it's just in a day we can do multiple jobs, and the difficulty of a day is the max difficulty of all of the jobs done in that day, right? And we get both like the days, the job's difficulty and the number of days. And what's the goal of the problem? We want the minimum difficulty of a schedule, of the entire schedule of those D days. If we can't find a valid schedule, we return -1. So let's take a look at an example here. We have these jobs and we have D equal to 2. So we have only 2 days. So the optimal thing is to do all of these jobs in D1 and do this one in D2, because then all of these values will be eliminated because the max is 6 and we take 1, and that's so the overall difficulty is 7 because the max for D1 is 6, the max for D2 is 1. Let's take a look at the second example. The second example, we actually can't do it because we need to do a task a day and we have 4 days but only 3 jobs, so we can't, so it's a -1. For the last one, we have 3 days and 3 jobs, so we can't do more than 1 job a day, right? So which means this one goes in D1, this one done in D2, this one in D3, and so the max for each one is 1 and the sum is 3, right? And that's pretty much it here for the examples. The job length is 300 at most and days is 10, so it's not too long. So how can we solve this problem? Okay, so let's see how we can solve this. So looking at the example here, it says we need to finish all jobs for a day before we attack ith job. We need to finish all those smaller than it, and each day we need to do at least 1. So definitely and we want to minimize the difficulty, right? So it definitely sounds like we can use some sort of recursion with caching, right? Where we just explore all possibilities, right? So we have this array, so explore all possibilities. So explore doing in day 1 just 6 and doing in day 2 all of these, that in this example. Then we explore and we record the difficulty of that schedule, right? Remember, we want the minimum difficulty. And then after that, we explore another one. So we explore the cutting here, basically giving day 1 6 and 5, and then giving the second day 4 3 2 1. And then we record the difficulty. We do the min each time, right? Because we want the best one. And then we try here, giving day 1 all of these and day 2 all of these. Basically, we try all possible divisions of the days. Here, it's just 2, so we try cutting here, cutting here, cutting here, cutting here, right? If we have like maybe 3 days here, then we'll try first cutting here and here, then we'll try cutting here and here, then we'll try cutting here and here. So we'll try all the variations until we record each time the difficulty using the min, and we take the best one, right? So that strategy should work, right? We could try to explore greedy solutions and see if there is a pattern we can use, but there is not really one that works for all examples. So let's see how we can solve this. Okay, so what should be the state of our recursive function? Since we are doing sort of cuts here for each day, we are deciding where to cut. Let's call our recursive function just cut here. well, what do we need to pass? Well, we definitely need to pass where we are in the index of the array and how many days left. Let's call how many days left just D, right? Okay. So when do we know we are done? Once we have only 1 day left, right? And let's say I maybe is at this position. Let's say maybe I is at this position. Then at that point, we know we have to take everything. We have to take all of these. We have to take all of these for that day. So all of the remaining ones. So from I to the end, we have to take it for that day once it's only that day remaining. So that's kind of our base case. So our base case is if D equal to 1, we know that we need to, for that day, we need to take from I, let's call it, so for job difficulty here, I'll just call it A to make this simpler to write. And so we know we have to take from I on to the end. But the difficulty of a day is the max of all of those jobs we do in that day. So here we need to return the max. The max for all jobs from I. So that's our base case. Now, what is our recursion? So when you are at I, let's say here, when you are here at a position I, we need to explore multiple possibilities. We need to explore taking just 4 for that day, or taking 4 and 3, or taking 4 and 2, or taking everything, if that's possible, right? So how do we write that? Well, we can write that with just a for loop, right? What did we do? So let me just write this down here. 6, 5, 4, 3, 2, 1. So if we are here, what did we take? What do we want to do? So we want to try 5, right? Or 4 or 3. So we can just do a for loop for an index j, maybe in the range of, we can't take before because those before were taken by the previous days. So we have to do for I to up to the end. So let's say n is the length of A, of the jobs. Are we allowed to take up to n? Well, not really, because we have to leave something for the remaining days, right? So how do we leave something for the remaining days? We have to go all the way up to n minus the number of days left so that we can leave D for the days left, right? And so here it has to be minus D. But we need to also do +1 for Python to stop at n minus D, right? Okay. So let's bring this for loop up here. Okay. So we do that for loop. Now what should we do in the middle? So what this for loop means is that from I to j, we'll do from I to j in D in the current day that we are exploring here with this D. Okay. So what we want to do is we want to get the difficulty for this day, which is the max of all those jobs in this day. So it's the max from I to j. And so we need to keep track of that max. Let's call it max D. Let's give it 0. And so what do we want to do here? Well, we want to calculate if that's the max. So we do the max of the max D so far and the value at that position j. Okay? And now what do we want to do? We want to recurse, right? So once we decide, okay, we are taking up to maybe, we are taking up to 3 for D2 maybe, or D, let's say this is 3 and for D2. Then to iterate for the next day, we call it on j+1 where we stop it for this day, right? And so to do that, well, we need to recurse on this function, right? And we need to call cut on j+1 because that's where we stop it for the current day. The current day is from I to j. And we've done the current day, which is D, so we have D-1 days left. Okay? But remember, what we are calculating is the minimum difficulty of the entire schedule. So we need to add the difficulty of this day to the next state. So we want to do max D plus this, right? Okay, let me just move this down a little bit here. to leave some space. Okay. But we also want to record the minimum difficulty so far, so that we return it. So we here best, and we can give it a high number like infinity. And here we want to take the min. So here we want minus infinity, infinity, so that min works. So we want to take min of this and best so far. And we want to assign this to best. And then at the end, we want to return best. And we can call the function cut with the start, which is 0 in the number of days. And then we return that, okay? So again, to reiterate, what we are doing is just for each day, we try taking all the different variants possible. And we just calculate the difficulty of that day, add it to that particular schedule, and see if that's the best one. And once we write this function, we can cache it so that it passes with a big number of for the number of jobs or for the number of days. So that's pretty much the idea. Let's implement it. Okay, so what do we need? We need to define our function cut with I and D. And first we have our base case that we mentioned in the overview. And we need to have just these two variables to calculate the state for the current day. And then we want to go through all the possible cuts for the current day, all the possible jobs we can take for the current day. And for each one, we calculate the difficulty for, so max D, this is the difficulty for day I, difficulty for day D. And so that's why we take the max. And then here, best is basically the entire difficulty, the difficulty of schedule. Okay. And then we return best at the end. And then we want to call this returning cut for 0 and D, the number of days. You can call this D left if you want, or left. Both work. Now, one edge case we want to handle is, so first we need to do this length, and I want to rename this to A to make it easier to write. Now, if the number of jobs is smaller than the number of days, then we can't do a solution because we need to do a job at least one job every day. So if n is smaller than the number of days, we want to return -1 because there is no solution. Otherwise, we return this. And that's pretty much it. So let's make sure it works correctly on some examples. Okay, so that seems good. Now we just need to add some caching here. So maybe let's call our cache here something like this. And we need to check if these two are in cache. We want to return cache for ID. And then we want to add set in the cache here. So that would be equal to best. And we want to return that. Okay. You can also use like something like Python's LRU cache, maybe with max size being none or something like that. Both work. Okay, so let's run this. Okay, let's submit. So this is just so that we cache the repetitive states, right? Let's say if we call 2 on day 2 again multiple times, because that's possible with this loop, we want to reuse the same value we obtained before. Okay, so that passes test cases. Yeah, so I think that's pretty much it for today's problem. Please like and subscribe, and see you on the next one. Bye.